Okay, today we're going to be going over the double angle formulas. Now, the double angle formulas cannot be used with the unit circle, as if you try to double any angle on the unit circle, you will also find something that's on the unit circle, or at least coterminal to it. So, looking at the formulas, for sine of twice theta will give us, simplified, it will be 2 times sine of theta times cosine of theta. If we are looking for cosine of 2 theta, then cosine of 2 theta can be written in one of three equivalent forms, depending on what you have or what you need. Well, not what you need, but what you have in the first place. One might be easier than the other. The different forms come more importantly for a different topic later on. And then tangent of 2 theta, which isn't actually bad. It's the double angle formula for tangent is really the nicest one that we have. So, yeah. Anyways, we're going to be using the same sort of situation for all of these problems. We're going to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta, and then we're going to do one extra one for the fun of it, and I believe that's cosine of 4 theta, because who doesn't just love a little bit of fun? Anyways, so given that sine of theta is 2 over 3, and theta has its terminal side in the first quadrant, find the exact value of each function. Well, I know that sine of 2 theta is 2 sine of theta cosine of theta, according to that identity we just looked at. Which means, just like when we did the sum and difference identity, I have 2 times sine of theta, which I do know, but I don't know cosine of theta. So guess what I have to find? Easiest way to do this is probably with the triangles. You can also use the identities to figure it out. But it said it's in the first quadrant. So sine is the opposite over the hypotenuse. Pythagorean theorem will give us our third side. It's a squared plus 2 squared equals 3 squared. So a squared plus 4 equals 9. So a squared equals 5. So a is plus or minus the square root of 5. In this case, we want the positive 5. Okay, good. Now that we got that, so we're looking for cosine. Cosine is the adjacent, which is the square root of 5, over the hypotenuse, which is 3. Now we just have to simplify. When you multiply fractions, you multiply straight across the top. So 2 times the square root of 5 gives us 4 square roots of 5. Now on the bottom, 1 times 3 is 9. This doesn't reduce, so this is the answer. Next one, cosine of 2 theta. We can use any of the forms that we want. I think I'm going to use cosine squared theta minus sine squared theta form. Again, you could have used any of the forms. They're all equivalent. I just chose to use this one. No particular reason why. Now, I will tell you, if I had not been finding like sine of 2 theta and the other trig functions, using the version with just sine in it, because that's what I'm given, would have been easier. But since I already had to make the triangle, it doesn't really matter which version I use. Anyways, cosine is the square root of 5 over 3. And sine is 2 over 3. The squareds mean that we're going to have to square them next. So the square root of 5 squared is 5 over 3 squared, which is 9. Minus 2 squared, which is 4 over 3 squared, which is 9. And lastly, to add or subtract fractions, since we have the common denominator, just subtract the tops here. So 5 minus 4 is 1, keeping my bottom the same. So 1/9 is cosine of 2 theta. Okay, next we have tangent of 2 theta, and tangent of 2 theta's formula is, it's 2 times tangent of theta over 1 minus tangent squared theta. So again, it's tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. So all we have to do is plug in the value for tangent into each position. So 2 times tangent, which is the opposite over adjacent, 2 over the square root of 5, not pretty, over 1 minus 2 over the square root of 5 squared. I'm going to simplify top and bottom separately. So focusing on the top here, 2 times 2 is 4 over the square root of 5. On the bottom, I'm going to have 1 minus. When you square that fraction, you square the top, giving you 4, and the bottom, square root of 5 squared is just 5. We still need to combine the bottom stuff before I can do anything else. So 1 minus 4 over the square root of 5. Well, 1 in terms of fifths is 5 over 5. So 5 fifths minus 4 fifths is 1 fifth. So on the bottom we get 1 fifth. On the top we still have our 4 over the square root of 5. What do you keep, change, flip next? 4 over the square root of 5 times 5 over 1 gives us 20 over the square root of 5. We do have to rationalize by multiplying by the square root of 5 on top and the square root of 5 on the bottom, giving us 20 square roots of 5 over 5. With our final step, it reduces to 4 square roots of 5. Now, there is another way we could do this. So if you want to know the other way, here it is. Nice and simple. It's actually a lot quicker for tangent of 2 theta. Instead of using the actual tangent of 2 theta formula, you can use one of the identities from the other day. And that is that tangent is equal to sine over cosine. In this case, the inside angle has to be the same, so in this case it will be sine of 2 theta over cosine of 2 theta. It's just the identity we had the first day we started doing identities. We found sine of 2 theta on the other page, and it was 4 radical 5 over 9 on the other page. We also found cosine of 2 theta to be 1 over 9. If you keep, change, flip this, 4 square roots of 5 over 9 times 9 over 1, you still get 4 square roots of 5. And it's a lot easier if you had to do sine of 2 theta already and cosine of 2 theta. If you didn't have to do those two in the first place, then doing this long process is probably the easier route to go. Now, one last one. We have cosine of 4 theta. Well, for cosine of 4 theta, that means we're going to end up using the angle formula in a different way. So normally the formula is that cosine of 2 theta is equal to, I think I'm just going to use the one without the radical. I'm going to use one of the other ones. So I'm going to use the 2 cosine squared theta minus 1 version. Now, since we have cosine of 2 theta here, cosine of 4 theta, that means the angle that's being doubled is really 2 theta. So we're doubling 2 theta, not just theta, we're doubling 2 theta. So over here in the actual formula, theta, what's being doubled, is no longer just theta, it's 2 theta. We're doubling theta, but now we're doubling 2 theta. So when I use this formula, theta on this side is not going to be theta, but 2 theta. So writing it out, cosine of 4 theta becomes 2 cosine squared of 2 theta minus 1. Now, had we not done this earlier, we would have to do a lot more work, but we already know what cosine of 2 theta is. We found it earlier. We found out that cosine of 2 theta in this particular problem is equal to 1/9. Therefore, we have 2 times 1/9 squared, because we have cosine squared, minus 1. 1/9 squared is 1/81. So 2 times 1/81 is 2 over 81. We need a common denominator. 1 in terms of 81st is 81 first. Yeah, 81 over 81. I give up trying to figure out how to actually word that. So 2 minus 81 is negative 79/81. Isn't that just beautiful?